Good evening, everyone. Good evening. Good evening. I welcome you all again to EJ Enthuse. I hope you guys are doing great, having a good time. So, people, first of all, you can let me know in the chats if I'm audible and visible to everyone. Hello, Aisha. Hello, Ashwarya. Hi, Chitra. Hello, Ishpreet. Hello, Harsan. Welcome back. Welcome back. Welcome back. Just let me know in the chats, first of all, if I'm audible and visible to everyone. Give me some green signal from the chat box first, yeah? Perfect. Perfect. All right, I'm doing great, Ashwarya. I'm doing great, Ishpreet. How are you doing? So, people, tonight it's going to be our fourth session from the chapter Redox. And in the last session of Redox, if you remember, we started with the N factor calculation, right? And your tonight's session is again going to be your N factor calculation only, right? We'll be continuing with the N factor calculation only with the tonight's session as well, right? So before starting the session, the ones who are new to the channel, let me introduce myself. Well, people, my name is Wassim Sir and I'm your chemistry master teacher writer on this JEE Enthuse channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, right? Okay. So people, in the last session, if you remember, we talked about how to calculate N factor for ions, right? We saw how do we calculate the N factor for the elements, N factor for the salts, N factor for the acids, N factor for the bases, right? And I showed you how do we calculate the N factor of the oxidizing and reducing agents as well. And in the last session only, we saw few important reactions of your KMnO4 as well, right? Those were the things which we have covered in the last session, right? Let's continue from there in the tonight's session. And in the tonight's session, we are going to talk about one more oxidizing agent that's called as K2Cr2O7, right? Potassium dichromate. K2Cr2O7, or you can write it simply as Cr2O7 dinegative. It is one more oxidizing agent like your KMnO4, right? Okay, this Cr2O7 dinegative, or you can call it simply as K2Cr2O7 potassium dichromate. It is one more oxidizing agent like your KMnO4, okay? So first thing which I want you guys to remember, whenever potassium dichromate, whenever K2Cr2O7, whenever Cr2O7 dinegative participates in the acidic medium, it gets converted into Cr tripositive. Whenever Cr2O7 dinegative, or you can call it directly as K2Cr2O7, when it participates in the acidic medium, it gets converted into what? It gets converted into Cr tripositive, right? First of all, if I'll ask you, what is the oxidation state of chromium right here? When we calculate it, the oxidation state of chromium comes out to be +6, right? If I ask you what is the oxidation state of chromium right here, you'll say it's +3, right? So people, just have a look on the change in the oxidation state of chromium, right? The oxidation state of chromium is changing from +6 to +3. The oxidation state of chromium is changing from +6 to +3, right? That means oxidation state of chromium is decreasing. Decrease in the oxidation state is what we call as reduction. So this whole compound will be undergoing the reduction, and that substance which undergoes reduction is what we call as oxidizing agent, right? So your Cr2O7 dinegative, or you can write it as K2Cr2O7, it acts as the oxidizing agent. Point number 1, right? Now how do we calculate its N factor? What you simply need to do, you need to simply calculate the change in the oxidation state of chromium. I'm calling this as the initial oxidation state of chromium. I'm calling this as the final oxidation state of chromium, right? Let's calculate change in the oxidation state of chromium, which is final oxidation state of chromium minus initial oxidation state of chromium. The value comes out to be 3. 3. Should I be calling this 3 as the N factor of K2Cr2O7? No way. I won't be calling this 3 as the N factor of K2Cr2O7. This 3 is basically change in the oxidation state for one atom of chromium. This 3 is basically change in the oxidation state for one atom of chromium. But currently I have 2 atoms of chromium. So I'm multiplying this term by 2. The value comes out to be 6. So remember, N factor of K2Cr2O7 in acidic medium, it's going to be 6, and you are going to remember it from now onwards, right? Okay, absolutely guys, you are going to remember it from now onwards. Yeah? Aisha, potassium is the spectator ion. Its oxidation state does not change in the reaction, right? Okay. Now people, there are some important reactions for this K2Cr2O7. Let me make you familiar with those reactions of K2Cr2O7, right? Understand. The first reaction, K2Cr2O7 converts Fe di positive into Fe tri positive. It converts Fe di positive into Fe tri positive. Okay. See guys, remember, if I need to write the reaction, you need to write it like this. K2Cr2O7. It converts Fe di positive. In which medium? In acidic medium. Into what? Into Fe tri positive. And itself, K2Cr2O7 in acidic medium gets converted into Cr tri positive. And with this, you'll be writing H2O as well, right? This is the reaction. This is the reaction which will happen when K2Cr2O7 will react with Fe di positive in acidic medium, right? This is the reaction which you are going to remember. Okay. Krishna, next session for Mission IIT series is tomorrow. Yeah. Okay, now people, if I want you guys to calculate the oxidation state of this K2Cr2O7, as I told you a few minutes back, oxidation state of K2Cr2O7 in acidic medium, sorry, not oxidation state, N factor, right? N factor of K2Cr2O7 in acidic medium is going to be 6. So you're not going to calculate it again and again. Once for all, you're going to remember it. The N factor of K2Cr2O7 in acidic medium is going to be 6, right? If I ask you what is the N factor of this Fe di positive, this +2 is the initial oxidation state of iron right here. +3 is the final oxidation state of iron. +2 to +3, what is the change in oxidation state? Final oxidation state minus initial oxidation state, value comes out to be 1. So N factor of this Fe di positive over here is going to be 1 only, right? Okay, I'm sure it's clear to everyone. Perfect. Reaction number 1. Now let me write the reaction number 2. Let me write the reaction number 2. See guys, remember K2Cr2O7, which is the oxidizing agent, it converts oxalate ion into carbon dioxide. It converts oxalate ion into carbon dioxide. What is the reaction which you are going to write? You'll be writing the reaction like this. K2Cr2O7 converts oxalate ion in acidic medium into carbon dioxide. Itself gets converted into Cr tri positive, and with this you'll be writing H2O as well, right? This is the reaction which is going to happen. Yeah. Now, is K2Cr2O7 participating in the acidic medium? Yes. And whenever K2Cr2O7 participates in the acidic medium, its N factor is going to be 6, as you all must be familiar with, right? What about the N factor of this oxalate ion? Let me calculate the oxidation state of carbon, which is going to be 2x minus 8 is equal to minus 2. So the value of x comes out to be +3, right? So +3 is the oxidation state of carbon over here. What about the oxidation state of carbon right here? It's going to be +4. So oxidation state of carbon is changing from +3 to +4. So what is the change in the oxidation state of carbon? It's going to be final oxidation state of carbon minus initial oxidation state of carbon. The value comes out to be 1. 1 is the change in the oxidation state for one atom of carbon. But I have 2 atoms of carbon, so I'm multiplying it with 2. The value comes out to be 2. So remember, N factor of this oxalate ion, comes out to be 2 in this reaction. I'm sure it's clear to everyone, right? And if you got to know the N factor of oxalate ion, you can calculate its equivalent mass in the reaction, right? Its molar mass divided by its N factor. That's all. Yeah? Okay. Absolutely. Let's move on to one more reaction. The same K2Cr2O7, it converts I negative to I2. Let's write the reaction. K2Cr2O7 converts I negative in acidic medium. To what? K2Cr2O7 converts I negative in acidic medium to I2, right? Itself gets converted into Cr tri positive, and with this you'll be writing H2O as well. Yeah? Right? Now guys, have a look. K2Cr2O7, it's participating in the acidic medium. And when K2Cr2O7 participates in the acidic medium, its N factor is going to be 6, right? What is the oxidation state of iodine? Over here, it's -1. What about the oxidation state of iodine? Over here, it's 0. So -1 to 0. What is the change in oxidation state? -1 to 0. What is the change? Final oxidation state minus initial oxidation state. The value comes out to be 1, right? So N factor of this I negative in this reaction is simply going to be 1. As simple as that, right? Right, people? Let me move on and let's talk about few more reactions. Remember, your K2Cr2O7, it converts H2S. It converts H2S. In which medium? In acidic medium. Into what? Into S, and itself gets converted into Cr tripositive, and with this you'll be writing H2O as well. This is the reaction that's going to happen, right? Right? This is the reaction which is going to happen. Since K2Cr2O7 is participating in the acidic medium, its N factor is going to be 6. Right? Its N factor is going to be 6. Similarly, you can calculate the N factor of this H2S over here. It's simple, right? You can do that. Yeah? You can do that. I'm sure about it. Yeah? I'm directly moving on to one more. The same K2Cr2O7. The same K2Cr. These are some important reactions, guys. So you need to remember these reactions. Then only we can do the questions based on the titrations, right? K2Cr2O7, it converts H2O2. In which medium? In acidic medium, into O2, and itself gets converted into Cr tripositive, and with this you'll be writing H2O as well, right? Now have a look. Have a look exactly. What is the oxidation state of chromium over here? It's going to be +6. Or let me not calculate the oxidation state of chromium, right? Because we know already when K2Cr2O7 participates in the acidic medium, its N factor is going to be 6, right? If I ask you, what about the oxidation state of this oxygen over here? Since it's hydrogen peroxide, and in hydrogen peroxide, the oxidation state of oxygen is -1. The oxidation state of this oxygen is 0. -1 to 0. -1 to 0. Calculate the change in oxygen state, which is going to be equal to final oxygen state minus initial oxygen state of oxygen. The value comes out to be 1. 1 is the change in the oxidation state. 1 is the change in the oxidation state for 1 atom of oxygen, but our 2 atoms. So 1 multiplied by 2 comes out to be 2. So N factor of this H2O2 in this reaction is simply going to be 2, right? Yes, I'm sure it's again clear to everyone, right, people? Yeah? Let me focus on few more reactions of your K2Cr2O7, then only we can do some questions, right? Maybe this is the last reaction. I do not remember. See, the same K2Cr2O7, it converts Sn dipositive in acidic medium into Sn plus 4, and with this your K2Cr2O7, it gets converted to Cr tripositive, and with this you'll be writing H2O as well, right? So first of all, K2Cr2O7, it's participating in the acidic medium, and when it participates in the acidic medium, its N factor is going to be 6, right? Oxidation state of tin over here is +2, right here is going to be +4. So from +2 to +4, what is the change? From +2 to +4, what is the change? Final oxidation state minus initial. The value comes out to be 2. So 2 is the N factor of this Sn dipositive over here in this reaction, right? I'm sure, again, it's clear to you. Right, people? Yeah? Okay. Okay, this is one last reaction of K2Cr2O7, and with this we'll be trying to solve some important questions from the N factor calculations, right? See, guys, your K2Cr2O7, it converts SO2 in acidic medium into SO4 dinegative. Itself gets converted into Cr tripositive, and with this you'll be writing water as well. Its N factor is going to be 6, right? Let's calculate the N factor of this SO2 over here. Sulfur over here has got the oxidation state of +4, and sulfur right here has got the oxidation state of +6, right? So from +4 to +6, what is the change in oxidation state? Final minus initial. The value comes out to be 2. So 2 is simply going to be the N factor of SO2 over here. 2 is simply going to be the N factor of SO2 over here, right? Well, if you got to know how to calculate the N factors, you can easily calculate their equivalent masses, right? By simply dividing their molar masses by their respective N factors. I'm sure it's clear to everyone. You can let me know in the chats. You can let me know in the chats if it's clear, right? Okay, now people, it's time to solve some questions. Or before solving the question, let's talk about hydrogen peroxide. See people, there are some species which in some reactions act like the oxidizing agents and in some reactions they act like the reducing agents, right? Okay, there are some species which sometimes behave like the oxidizing agents and sometimes they behave like the reducing agents, right? And the common example in those species is hydrogen peroxide, right? Your hydrogen peroxide, which is H2O2, sometimes it behaves like the oxidizing agent and sometimes it behaves like the reducing agent. In some of the reactions you will find out this H2O2 gets converted into O2, and in some of the reactions you'll find out this H2O2 gets converted into H2O, right? Now people, what is special over here? Have a look. The oxidation state of this oxygen over here is -1. Oxidation state of this oxygen is 0. Oxidation state of this oxygen is -2, right? Okay. Now guys, have a look. In the first reaction, when H2O2 will be getting converted into O2, when H2O2 will be getting converted into O2, is this H2O2 at that time going to act as the oxidizing or reducing agent? Let's check it out. -1 to 0, increase in oxygen state. Increase in oxygen state is what we call as oxidation. And that substance which undergoes oxidation, that will be acting as the reducing agent. So in the first reaction, H2O2 acts as the reducing agent. In the first reaction, H2O2 acts as the reducing agent, right? Similarly, in the second reaction, -1 to -2, -1 to -2, decrease in the oxygen state. -1 to -2, decrease in the oxygen state. Decrease in the oxidation state is what we call as reduction. And that species which undergoes reduction is called as oxidizing agent, right? So H2O2 in the second reaction will be acting as the oxidizing agent. In the first reaction, H2O2 acts as a reducing agent. In the second reaction, it acts as the oxidizing agent. So now, when H2O2 acts as the reducing agent, what is going to be its N factor? When the same H2O2 acts like the oxidizing agent, what is going to be its N factor, right? Let's calculate it. See guys. N factor of H2O2 when it acts as the reducing agent. See, this is the initial oxygen state, this is the final oxygen state. Final minus initial. Final is 0, initial is -1, the value comes out to be 1. 1 is the change in the oxidation state for one atom of oxygen, but I have two atoms of oxygen, so I'm multiplying it with 2. So the N factor of H2O2, when it acts as the reducing agent, it's going to be 2, right? Yeah. In the second case, when the H2O2 acts as the oxidizing agent, what is going to be its N factor? N factor of H2O2 when it acts as the oxidizing agent. -1 to -2. Calculate the change in oxygen state. Final oxygen state of oxygen minus initial oxygen state of oxygen, the value comes out to be 1, right? 1 is the change in the oxidation state for one atom of oxygen, but I have two atoms of oxygen, so I'm multiplying it with 2. The value over here comes out to be 2. So remember H2O2, whenever H2O2 will be acting as the reducing agent or the oxidizing agent, in both the cases, N factor of H2O2 is going to be 2, right? Okay? Yeah? N factor of H2O2, if it acts as the oxidizing or reducing agent, in both the cases it's going to be 2, right? Wow, that's great, Amir. That's nice to hear. That's great. Congratulations. Let me know fast if it's clear. Okay, one more thing, guys. One more thing. Like this hydrogen peroxide, we have got one more species which sometimes acts as the oxidizing agent and sometimes it behaves as the reducing agent. That is FeSO4, ferrous sulfate. FeSO4. In some reactions, it gets converted into Fe tripositive. In some reactions, it gets converted into Fe, right? If I ask you what is the oxidation state of iron right here, you'll clearly say it's +2. What about the oxidation state of iron right here? It's +3. What about the oxidation state of iron right here? It's 0, right? So +2 to +3, increase in the oxygen state. Increase in the oxygen state is what we call as oxidation, right? So this FeSO4 in the first reaction, right? It undergoes oxidation, so it will be acting as the reducing agent, right? So in this reaction, the FeSO4 acts as the reducing agent, right? Now, +2 to 0, +2 to 0, decrease in the oxygen state. Decrease in the oxidation state is what we call as reduction, right? Okay, and any species which undergoes reduction will be acting like the oxidizing agent. In the second reaction, the same FeSO4 acts as the oxidizing agent, right? Now people, let's calculate the N factor of this FeSO4. N factor of FeSO4 when it acts as a reducing agent. N factor of FeSO4 when it acts as a reducing agent will be equal to change in the oxidation state of iron in the first reaction, which is going to be equal to final oxidation state of iron minus initial oxidation of iron. The value comes out to be 1, right? Okay, one is the change in the oxidation state of one atom of iron, and over here I've got only one atom of iron. So N factor of FeSO4 when it acts as a reducing agent is simply going to be 1, right? Okay. Similarly, have a look. Plus 2 to 0, plus 2 to 0, plus 2 to 0. Calculate the change in oxygen state, which is going to be equal to final oxygen state 0 minus initial oxygen state, that is plus 2, right? Plus 2, the value comes out to be 2. 2 is the change in the oxidation state. 2 is the change in the oxidation state for one atom of iron, right? And over here I've got one atom of iron only, right? So N factor of FeSO4 when it acts as the oxidizing agent again is going to be 2 over here, right? So whenever FeSO4 acts as a reducing agent, its N factor is going to be 1. Whenever FeSO4 acts as the oxidizing agent, its N factor is going to be 2. As simple as that. You can let me know in the chats if it's clear to everyone, so that I can move on to a few more interesting things. Let me know fast in the chats, guys. Let me know fast in the chats. Yeah? Perfecto. Wonderful. All right, this is the question for you. You just solve it. Let me know the N factor of this I2 in this reaction. Let me know the N factor of I2 in the reaction. I'm waiting for your answers. I'm waiting for your answers in the chats, right? Give it a try. Let me know its answer fast. Give it a try fast. Let me know fast in the chats, people. Okay, see exactly what is going to be the N factor of this I2. If I ask you what is the charge present on this iodine over here, you'll say 0. 0 is its oxidation state. What about the oxidation state of iodine over here? It's going to be simply plus 5, right? So from 0 to plus 5, calculate the change in oxygen state. From 0 to plus 5, calculate the change. Change is going to be final oxygen state of iodine minus initial oxygen state of iodine. The value comes out to be 5, right? 5 is the change in the oxidation state for one atom of iodine, but I have 2 atoms of iodine. So 5 multiplied by 2 comes out to be 10. So 10 is basically the N factor of I2 in this reaction. 10 is basically the N factor of I2 in this reaction. So N factor of I2 in this reaction is 10, right? If I'll ask you, what is the N factor of this IO3 negative? What is the N factor of this IO3 negative? What you'll be doing? You'll be reversing the reaction. You will be calling this as the initial oxygen state, then you'll be calling this as the final oxygen state, right? Calculate the change in the oxygen state, which is going to be equal to final oxygen state 0 minus initial oxygen state plus 5, right? Value comes out to be 5. 5 is the change in the oxidation state for one atom of iodine, and over here only I've got one atom of iodine. So its N factor is going to be 5, as simple as that. Yeah? I'm sure it's clear to everyone. One more question for you. Calculate the N factor for this N2H4 in this reaction. We can do this as well, right? Let's calculate the N factor of nitrogen. Let's first of all calculate the oxidation state of nitrogen, right? It's going to be 2x plus hydrogen shows plus 1, 4 hydrogen atoms, net charge is 0. So x value comes out to be minus 2, right? So nitrogen over here shows the oxidation state of minus 2. What about the oxidation state of nitrogen over here? It's going to be plus 5, right? It's going to be plus 5 when you solve it. So minus 2 to plus 5, calculate the change. Final oxygen state minus initial oxygen state, the value comes out to be 7. 7 is the change in the oxidation state for one atom of nitrogen, but currently I have 2 atoms of nitrogen. So 7 multiplied by 2 comes out to be 14. So N factor of this N2H4 in this reaction is 14, right? Yes. Yes, science rocks. There are some special cases as well. You'll get the idea in some time. Just wait for it. Yeah. All right. One more for you guys. What is the N factor of IO4 negative in this reaction? What you'll be doing? You will be calculating the oxidation state of iodine over here. It will come out to be plus 7. You'll be calculating the oxidation state of iodine over here. It's going to be 0. Plus 7 to 0. What is the change? Final oxidation state of iodine, which is 0, minus initial oxidation state of iodine, which is plus 7. The value comes out to be 7. 7 is the change in the oxidation state for 1 atom of iodine. And currently I've got only 1 atom of iodine. So its N factor is simply going to be 7 only, right? So N factor of IO4 negative is simply going to be 7. I'm sure it's clear to everyone, right? Yeah? Perfect. One more for you. Calculate the N factor of VO in this reaction. First of all, the oxidation state of vanadium over here is +2. The oxidation state of vanadium over here is +5, right? So +2 to +5. What is the change? Final minus initial. Value comes out to be 3. 3 is the change in the oxidation state for 1 atom of vanadium. And over here, only 1 atom of vanadium I have. So its N factor is simply going to be final minus initial. That comes out to be 3. So N factor of VO is going to be 3. As simple as that, right? Yes. Similarly, N factor of this species over here. How do we calculate N factor of this species? First of all, let me calculate the oxidation state of this iron, right? Let's assume the oxidation state of the iron is X, right? Multiplied by 0.94. Oxidation state of oxygen is -2, right? Multiplied by how many oxygen atoms? 1. Net charge on it is 0. So X value will come out to be 2 divided by 0.94, which you can write as 200 divided by 94, right? Plus 200 by 94. This is the value of X. Plus 200 divided by 94. This is the oxidation state of iron over here. This is the oxidation state of iron over here. Average oxidation state of iron, right? Now this iron is getting converted into this species, right? Over here the oxidation state of iron is +3, right? So from here to here, this is the initial oxidation state of iron. This is the final oxidation state of iron. Calculate the change in the oxidation state of iron, which is going to be equal to final oxidation state of iron minus initial oxidation state, which is 200 divided by 94. This is the change in the oxidation state for 1 atom of iron. And how many atoms of iron do we have? 0.94. So I'm multiplying it with 0.94. Just solve this value. This is going to give you the N factor of this species over here, right? Yes, I'm sure it is clear to everyone. You can let me know. You can let me know in the chats if it is clear fast. Fast people, fast, fast, fast. Right? Visualized learning. Just do one thing, bro. Drag the video a little back. It'll be automatically a replay for you. Yeah? So Science Rocks is saying the answer comes out to be 0.81. All right? 0.81 is then going to be the N factor of this species over here. I'm sure it's clear, right? Perfect. All right, now come some special cases, guys. Now come some special cases. What are these special cases all about? You need to understand these special cases one by one, okay? See, till now, I calculated the oxidation states. Sorry, till now, I calculated the N factor of those species in which oxidation state of only one element used to change, right? Till now, I gave you only those compounds in which oxidation state of only one element used to change, right? Now, there are some other species as well in which oxidation state of more than one element changes, right? Oxidation state of more than one element either may increase simultaneously or may decrease simultaneously. One may increase, one may decrease, right? There are a lot of cases for that. There are a lot of cases for that, yeah? Let's try to understand those cases one by one. See, guys. N factor of the compound in which oxidation state of more than one element increases or decreases simultaneously, right? See, first of all, if I want you guys to calculate the oxidation state of this iron, you will say it's +2. Oxidation state of this carbon, it's +3, right? It's +3. Oxidation state of this iron, it's +3. Oxidation state of this carbon, it's +4, right? Now, +2 to +3, +2 to +3. Oxidation state of iron is changing. Oxidation state of carbon is also changing, right? Now understand one thing. Oxidation state of iron is increasing, and at the same time, oxidation state of carbon is also increasing. So I'll say this compound comes in the category in which oxidation state of two elements simultaneously increases, right? This compound, it comes into the category in which oxidation state of two elements simultaneously increases. How do I calculate the N factor of the substance in which oxidation state of two elements simultaneously increases or simultaneously decreases? What I'll be doing? I'll be calculating the change in the oxidation state of iron, which I'll be representing by N1. I'll be calculating the change in the oxidation state of carbon, which I'll be mentioning by N2, then I'll sum them up. I'll add them up. N1 plus N2. N1 plus N2 is going to give me the overall N factor of this species. That's all. How come? Have a look. See guys, iron is changing its oxidation state from +2 to +3. What is the change in oxidation state? Final minus initial. Final minus initial. The value comes out to be 1, right? So N1 value will be equal to 1, right? Similarly, +3 to +4. +3 to +4. What is the change in oxidation state? Final oxidation state minus initial oxidation state. So final is +4, initial is +3. The value comes out to be final minus initial comes out to be 1. But 1 is the change in the oxidation state for 1 atom of carbon. But currently I have 2 atoms of carbon. So 1 multiplied by 2 comes out to be 2. So N2 value is equal to 2. I got N1, I got N2. How do I calculate N factor of the substance in which oxidation state of 2 elements simultaneously increases? It's calculated by this formula N1 plus N2. That's all, right? N1 value you got, N2 value you got. So 2 plus 1 comes out to be 3. So 3 is basically N factor of this ferrous oxalate in this reaction, right? I'm sure it is clear to everyone, yeah? Exactly, guys, wonderful. Let's move on and talk about a few more cases. Have a look on this one as well. Okay, if I ask you what is the oxidation state of arsenic over here, you'll say +3. Oxidation state of sulfur over here, you'll say -2. Oxidation state of this AS over here, it's going to be +5. Oxidation state of this sulfur over here, it's going to be +6, right? See guys, +3 to +5. +3 to +5, oxidation state is increasing. -2 to +4, sorry, -2 to +6, oxidation state is increasing. Again, this is the compound in which oxidation state of 2 elements is increasing simultaneously. How do I calculate its N factor? Mod of N1 plus N2, that's all, right? Mod of N1 plus N2, that's all, correct? Now guys, see, +3 to +5, what is the change in the oxidation state of arsenic? +3 to +5. Change is final oxidation state minus initial value comes out to be 2. 2 is the change in the oxidation state for 1 atom of arsenic, but I have 2 atoms, right? So 2 multiplied by 2 comes out to be 4. So N1 value will be 4, right? -2 to +6, calculate the change. Final oxidation state of sulfur minus initial oxidation state of sulfur, the value comes out to be 8. 8 is the change in the oxidation state for 1 sulfur atom, but I have 3 sulfur atoms. So 8 multiplied by 3 is 24, right? So N2 value is equal to 24. Yeah? So this is the compound in which oxidation state of 2 elements is simultaneously increasing. How do I calculate its N factor? Its N factor is simply going to be equal to N1 plus N2. 24 plus 4 comes out to be 28. So 28 is going to be the overall N factor of this species over here. I'm sure it's clear, right? Right, people? Exactly. Let's move on. Okay, have a look. Let's calculate the N factor of this Cu2S over here. Understand, guys. Copper has got the oxidation state of +1, sulfur has got the oxidation state of -2. You can calculate it too, right? Just do the crisscross thing, which you would have studied in your class 9th as well, yeah? Cu dipositive, its oxidation state is +2, right? Sulfur, its oxidation state is +4, correct? Now people have a look. +1 to +2, oxidation state of copper is increasing. -2 to +4, oxidation state of sulfur is also increasing. So this is the compound in which oxidation state of 2 elements simultaneously increases. How do I calculate its N factor? Same, N1 plus N2, as simple as that, right? Have a look. Say, calculate the change in the oxidation state of copper, +1 to +2. +1, +2. Calculate the change, final minus initial. Final minus initial, value comes out to be 1. 1 is the change in the oxidation state for 1 atom of copper, but I have 2 atoms. So N1 value comes out to be 2, right? Say, -2 to +4, calculate the change. Final oxidation state of sulfur minus initial oxidation state of sulfur, the value comes out to be 6. 6 is the change in the oxidation state for 1 sulfur atom, and I've got only 1 sulfur atom, right? So N2 value is 6. So N1 you got, N2 you got, calculate its overall N factor. Its overall N factor is going to be N1 plus N2. So 6 plus 2 comes out to be 8. 8 is basically the overall N factor of this Cu2S in the reaction, right? I'm sure you're getting it all. Right, people? Clear to everyone? Yeah? Perfect. Let's move on then. Let's move on. Okay. Let's calculate the N factor of this species. You can now do this on your own. See how come. Just do the crisscross thing. It's going to be +3. This is going to be -2. As simple as that. This is going to be +5 and this is going to be 0. I calculated the oxidation states of all the elements, right? See, +3 to +5, increase in the oxidation state. -2 to 0, increase in the oxidation state. Again, how you'll be calculating its n factor? It's going to be n1 plus n2, right? See guys, +3 to +5, +3 to +5, +3 to +5. Calculate the change. Final oxidation state minus initial oxidation state. Final minus initial comes out to be 2, right? It comes out to be 2. So 2 is the change in the oxidation state for one atom of bismuth. I've got 2 atoms. So 2 multiplied by 2 is 4. N1 value comes out to be 4. What about N2 value? -2 to 0. -2 to 0. -2 to 0, right? Calculate the change. Final, that is 0, right? Initial, that's -2. Value comes out to be 2. 2 is the change in the oxidation state for one sulfur atom, but I have 3 sulfur atoms, so 2 multiplied by 3 is 6. So N2 value over here is 6. I got N1, I got N2. N1 plus N2 comes out to be 10, right? So N factor of this species will be 10. Well, if you got its N factor, you can calculate its equivalent mass, right? How come? Simply dividing its molar mass by its respect to N factor, that's all, yeah? People, is everything clear till here? Is every single thing clear till here? You can let me know in the chats, yeah? Then only I can move on to the next one. Okay, let's move on then. Okay, now comes one more category over here. This is one different category. N factor of the compounds in which oxidation state of one element increases and other decreases. Till now we were talking about those compounds in which oxidation states of more than one element simultaneously either increases or decreases. But now comes a compound in which oxidation state of one element will increase, another one will decrease. At that time, how do I calculate its N factor? Now in this case, it's going to be mod of N1 minus N2. In this case, it's going to be mod of N1 minus N2, right? How come? Have a look. First of all, just do the crisscross thing. The oxidation state of iron is going to be +3. The oxidation state of sulfur is going to be -2. Iron over here shows +2 oxidation state. Sulfur over here shows +4 oxidation state, right? Say guys, +3 to +2. What is the change? So +3 to +2, oxidation state is decreasing. -2 to +4, oxidation state is increasing, right? Oxidation state of one element is increasing. And at the same time, oxidation state of one more element is decreasing, right? So I'll be calculating the change in the oxidation state of both these elements. I'll be calculating the change in the oxidation state of our iron. I'll be calculating the change in the oxidation state of our sulfur as well, right? Okay. Now see how I'll be doing exactly it. See guys. First of all, let me calculate the change in the oxidation state of iron. This is the final oxidation state of iron. This is the initial oxidation state. Final minus initial comes out to be 1. 1 is the change in the oxidation state for one atom of iron, but I have 2. So for 2 atoms of iron, N1 value will be simply equal to 2. 1 was the change in the oxidation state for one atom of iron, but I have 2. So 1 multiplied by 2 comes out to be 2, right? So N1 value is 2. Similarly, -2 to +4. -2 to +4, calculate the change. Final oxidation state minus initial oxidation state, the value comes out to be 6. 6 is the change in the oxidation state for one atom of sulfur, but I have 3 atoms of sulfur, so 6 multiplied by 3 is 18. So N2 value is equal to 18, right? N2 value is equal to 18. Yes? Now guys, this is the compound in which oxidation state of one element increases and another element decreases, right? Whenever you'll be having such kind of a compound in which oxidation state of one element increases, another one decreases, how do I calculate its N factor? It's going to be mod of N1 minus N2. That's all. Mod of N1 minus N2, right? N1 value is 2. N2 value is 18. The value comes out to be 16. So 16 is the N factor of this species. If you got its N factor, you can calculate its equivalent mass. How come? Its molar mass divided by its N factor. That's all, right? Yes? Roy Abraham, I have no idea about it. Well, I need to check it out. Then I can let you know about it, right? I need to check it out. I'm sure it's clear, guys, okay? All right, one more case for the N factors. One more case for the N factors. N factor of a substance which undergoes disproportionation reaction. Okay? First of all, what is a disproportionation reaction? What's a disproportionation reaction? Understand. See guys, if I ask you what is the oxidation state of bromine right here, you'll say 0. What is the oxidation state of bromine over here? You'll say +5. What is the oxidation state of Br over here? You'll say -1. So 0 to +5, oxidation state of bromine is increasing, right? 0 to -1, oxidation state of bromine is decreasing, right? See guys, oxidation state of same species is increasing as well as decreasing simultaneously, right? Oxidation state of same species is increasing as well as decreasing simultaneously. Or I can say some part of Br2 undergoes oxidation and some part of Br2 is undergoing reduction at the same time. Whenever the oxidation state of same species increases as well as decreases simultaneously, we say the species undergoes disproportionation. It undergoes disproportionation, right? I'll say some part of Br2 is undergoing oxidation and the rest of the part of Br2 is undergoing reduction simultaneously, right? Okay. And this species, I'll say it will be simply undergoing disproportionation. How do I calculate N factor in disproportionation reactions? I'll simply tell you one trick, that's all. Say guys, 0 to +5, what is the change in oxidation state? Final minus initial, 5. 5 is the change in the oxidation state for 1 atom of bromine, but I have 2. So 5 multiplied by 2 comes out to be 10. So N1 value is 10, right? Similarly, 0 to -1, calculate the change. Change is final minus initial, right? Calculate the change. 1 is the change in the oxidation state for 1 atom of bromine, but I have 2. So 1 multiplied by 2 is 2. So N2 value is 2. So I got N1, I got N2. How do we calculate N factor of the substance which undergoes disproportionation? N factor of the substance which undergoes disproportionation is always equal to N1 N2 divided by N1 plus N2, right? N1 value is 10, N2 value is 2, divided by this is 10 plus 2. The value comes out to be 20 divided by 12, which is going to be 5 divided by 3. So 5 by 3 is basically the N factor of this Br2 in the reaction, right? Yes, I'm sure it's clear to everyone. Yeah? Okay, this is the simple way by means of which we can calculate the N factor of the species which undergoes disproportionation, right? Right, people? Pushpa Singh, I can do nothing about it. I'm really sorry. Yeah? May God be with you. Okay, this is one more reaction, guys, right? This is one more reaction. This is one more example of the disproportionation reaction, yeah? This is one more example of the disproportionation reaction. Now see, how do I calculate the N factor of this P4 over here? Understand? Understand, guys. If I ask you, what is the oxidation state of phosphorus right here? You'll say 0, right? As simple as that. What about the oxidation state of phosphorus right here? It's -3. What about the oxidation state of phosphorus right here? When you calculate it, it comes out to be +1, right? When you calculate it, it comes out to be +1. Okay, now 0 to -3, oxidation state of phosphorus is decreasing. 0 to +1, oxidation state of phosphorus is increasing, right? So I'll say oxidation state of phosphorus is simultaneously increasing as well as decreasing, right? Increasing as well as decreasing. I'll say this P4 will be undergoing disproportionation. This P4 is undergoing disproportionation. Yeah? And how do I calculate the N factor of the substance which undergoes disproportionation? Simply N1 N2 divided by N1 plus N2. I hope you remember it. Right? N1 N2 divided by N1 plus N2. Right, people? Now, 0 to -3. 0 to -3. What is the change in oxidation state? 3 is the change in the oxidation state for 1 atom of phosphorus. But I have 4 atoms. So 4 3s comes out to be 12. So N1 value is equal to 12. Right? Similarly, N2. 0 to +1. Change in the oxidation state is 1. 1 is the change in the oxidation state for 1 atom of phosphorus. Right? But I have 4 atoms. So N2 value comes out to be 4. I got N1, I got N2. So it's going to be 12 multiplied by 4 divided by 12 plus 4. It's going to be 48 divided by 16. The value comes out to be 3. 3 is going to be the N factor of this P4 in this reaction, right? 3 is the N factor of P4 in the reaction. I'm sure it's clear to everyone, right? Okay. Alright guys, one more last question we are going to solve. Yeah? Let me give you one more reaction over here. For example, the reaction which I'm giving you, it is H2O2 gives H2O plus O2. H2O2 gives H2O plus O2, right? See, The oxidation state of this oxygen is -1. The oxidation state of this oxygen is -2. Oxidation state of this oxygen is 0, right? Check it out. -1 to -2, decreasing. -1 to 0, increasing, right? So I'll say this H2O2 is undergoing disproportionation over here, right? And whenever the substance undergoes disproportionation, how do we calculate its N factor? It's going to be N1, N2 divided by N1 plus N2, right? Okay. -1 to -2. -1 to -2. What is the change? Final minus initial, right? Final minus initial. The value comes out to be 1. 1 is the change in the oxidation state for one atom of oxygen, but I have 2. So for 2 atoms of oxygen, N1 value comes out to be 2. -1 to 0. Final minus initial. The value comes out to be 1. 1 is the change in the oxidation state for one atom of oxygen, but I have 2. So for 2 atoms, N2 value is 2. You got N1, you got N2. So you are going to do something like this. 2 multiplied by 2 divided by 2 plus 2. The value comes out to be 1. So remember, whenever H2O2 undergoes disproportionation, its N factor is going to be taken as 1, right? Right, people? Whenever H2O2 undergoes disproportionation, its N factor is going to be taken as 1. As I told you a few minutes back, H2O2 is the substance which sometimes can act like the oxidizing agent, sometimes it can act as the reducing agent, and sometimes it can undergo disproportionation. If it acts as the oxidizing agent, its N factor is 2. If it acts as the reducing agent, N factor 2. If it undergoes disproportionation, its N factor is 1, right? Its N factor is 1. Yeah? Okay? Do remember this from now onwards. Correct, people? I'm sure every single thing is clear till here, right? So people, that's all from my side in the tonight's session. I'm sure you would have got the N factor calculation properly. The next session of this redox, which I'm going to take, which is going to be day after tomorrow, right? Tomorrow I'm going to take a session for JEE Advanced students, right? Day after tomorrow, I'll be taking one session in which we'll be doing the redox titration in detail, right? Equivalent concept, basically, we are going to discuss in the day after tomorrow session, which is one of the most important sessions, right? And people, if you have not enrolled into the pro subscription yet, I would suggest you guys to enroll into the pro subscription as soon as possible, because the next batch for the class 11 students is starting on 27th of September on the actual Vedantu platform, right? You have got 3 plans. You can select any of the plan for you, right? Let me make you understand these plans first of all. You have got 3 plans. One is light, one is your classic, and one is your plus, right? Light, classic, and plus. All these plans are basically valid for 2 years. These are 2-year classroom programs, basically. These are 2-year classroom programs. Point number 1. Point number 2. This much is the course fee for the entire 2 years. This much is the course fee for this program for the 2 years. This much is the course fee for the plus program for the 2 years. No need to pay this much of amount in one go. You can pay this much of amount in EMI as well. You can pay monthly EMI. Vedantu has kept an option for that, right? Well, what all things you are getting in the first light program? There will be live interactive online classes on the actual Vedantu platform apart from these YouTube sessions. Point number 1. Test series will be conducted, and later on you'll be getting to know about the analysis of the tests as well, right? Notes, and the best part is you'll be getting the study material, which is what we call as Tattva material, which is one of the best study materials across the country, right? People, if you are new to Vedantu, you have no idea how the actual Vedantu platform looks like. What I would suggest for you guys, do take the pro subscription for a month, right? Do take it for a month. Vedantu has kept an option for this as well. You can take the subscription as for a month. If you think you are getting benefited, you can then go enroll yourself for the 2-year classroom program, right? And trust me, you are going to love it. You're going to love it. Take it for a month, then automatically you'll be forcing yourself to take it for the 2 years, right? So same is the procedure for classic. This is the 1 month pro subscription fee, right? You can take all these pro subscriptions for a month, yeah? Okay, the batch is going to get started on 27th of September, right? In coming days, it's going to start, right? And people, while enrolling, do not forget to use this coupon code as WBPRO, right? If you use this coupon code, definitely you'll be getting some additional 10 to 20% off. And let me show you exactly how to get enrolled in the actual Vedantu platform, right? But before that, if you have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? Well, people, this is the video which you guys are currently watching. I'm just dragging the video a little down. I'm clicking on this show more. After clicking on this show more, you'll be getting a lot of links. There'll be one link which will be for the pro subscription. Let me find that link first of all. Just a second. Let me find that link. Where is that? Vedantu pro subscription link, right? Where is that? I think that link is missing over here. Is that? No. No, guys, have a look. This is JEE 2 years, right? JEE 2 years. Okay, this one is the link. This one is the link, right? You need to click on any one of these plans. If you're going to take light plan, click on this. If you're going for classic, click on this. If you're going for plus, click on this, right? For example, I'm going for light, right? Okay, you can either buy the complete course or you can try it out for a month, right? And use this coupon code of WBPRO, you'll be getting some 10% off. For example, I'm trying it for a month. I clicked on it and I'll be putting my phone number, email ID on which I'll be getting the OTP, and automatically I'll be getting into the batch, which is going to get started on 27th of September, right? By the teachers of your choice in your physics, chemistry, as well as mathematics, right? I'm sure people, you would have enjoyed the session, right? I'm sure you would have enjoyed the session. So if you'll have any sort of doubts, do let me know your doubts on the comment section afterwards, or you can text me on my Instagram ID, right? Which you all must be knowing now, Wassim Bhatt, WSSIMBHATT, right? You can go ahead with your queries in the comment section or Telegram or Instagram, wherever you find me, yeah? So with this, I'll take a leave. I hope you enjoyed the session. I'll see you guys day after tomorrow. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.